All right. Good afternoon, everyone. Happy St. Patrick's Day. How is everybody? Good. Can somebody confirm that you can hear me and you can see my screen? Oh, thank you so much. Okay. Are there any questions, anything? Try to. All right, so I'm going to upload a PowerPoint slide I have just created on Sakai so that you can follow along my lecture steps. Okay, it is a PowerPoint presentation. So lecture recordings resources. So under resources, lecture slide, and then I will upload a PowerPoint for today's lecture. So I'm going to send it also to your email. Okay. Okay, so you should have email for the PowerPoint slide today. All right, questions so far? Try to see who are here. Okay, most students are here. Okay. All right. You can ask questions throughout the lecture, okay? So I try to monitor my chart for my in-class students. If you have questions, maybe you can just directly speak up, or you can through the chart, okay? Okay, thank you. Okay, great. All right. So can someone confirm you got email about PowerPoint slide? Yeah. Oh, thank you so much. All right, so I'm going to just adjust my computer. So today we are going to do two lessons. Lesson 37, internal consistency, and lesson 38, item analysis. Okay. And remember, each week, we also have participation mark by doing a little exercise. This week, I haven't assigned yet, but it is about lesson 37 and lesson 38. Okay. All right. So let's go lesson 37 first. So what is consistency? If a measure is consistent, it should be free of measurement error. And if you repeat the measurement, you should get consistent result, similar result. Okay. In our textbook, we talk about 3 methods to create reliability coefficient to measure the consistency. We can test and retest. For test and retest, we are going to take two occasions, okay? Give participants a questionnaire, and then on another occasion, give them the questionnaire again. We want to say, collect those two occasions result to see if they are similar. Okay. Another method is the test retest. It is the equivalent forms. Again, it is need two occasions. So we create two different forms, but they are equivalent. And to see if they can come up with the same result. And the third method is our focus. It's important. We are going to use ITIS to do the third method. Internal consistency. Internal consistency, it is just one occasion. We just have one chance to test the consistency. And we have two methods. Method A, split half reliability. We divide the original items into two parts. Those two parts are equivalent. And then we test each part to see if they can come up with the same or similar results. And the other method is coefficient alpha. Coefficient alpha. Okay, so this internal consistency is our focus. There are three types of applications for internal consistency. The first type is no transformation is needed. Okay, if all the items use the same scale, all the items use the same scales, and all the items goes to the same direction, you do not need to make transformation. Okay, so for example, I want to evaluate how students feel about this course, ITIS3P91, and I created some items using the scale with 1 to 5, 1 unsatisfactory, 5 very satisfactory. And then I ask you the course management. Okay, you feel this course is organized. Okay, and then I ask you the assignment load. You feel the assignment load is appropriate. And then the instructor's teaching attitude and expert knowledge about this course. Again, every item is 1 to 5, with 1 represent highly satisfied. Okay, so in this situation, you do not need to do transformation. But sometimes the original data, we do need a transformation. We do need to reverse score of some item. Okay. We require all items must have the same response metric. All items must go into the same direction. Okay, but in some items, if the high score on some items represent lower score on the another constraint, in this case, we need to do the reverse. And we are going to see example in this lesson. Why do we need to do reverse? Because some items are not in the same direction with other items. After we do the reverse, all items are in same direction. And the third application is the Z-score transformation. Okay. If you have different response metrics, you need to transform all the items into z-score so that they have the same response metric. All variables go into the same direction. So those are the three types of applications. Now we'll go to an example. Under what circumstances you can reverse scale? Okay, I give you a moment to read this context by yourself. So in this example, you have some item about keep emotions under control. And you also have some items express emotions openly. Okay, so two categories of your variable. One is keep emotions under control. The other is keep emotions openly. Those are two different directions. So those, one is under control, the other is express emotion openly. So they are go different directions. If you see items goes to different directions, you need to reverse. Okay, you need to reverse so that all items go to the same direction. In this case, the expression items need to be reversed. Okay, because our target is keep emotions under control. If you ask, can I reverse keep emotions under control? Of course, you can do that. Okay, but you have to interpret the meaning. Okay, because our objective here, you see, we want to use the emotion control scale. In this case, you have to reverse, express emotions openly, depending on your objective. If your objective is to use emotional openly express your emotions, you can reverse the other one. So anyway, all the items should go to the same direction, okay, not two different directions. So this is one example why we need to reverse. Okay. And the next example is about transform all items to z-score. Again, I give you a few moments to read over the text. Okay, as you can see from this example, the questions about very dynamic aspects of a student life. So questions ask you, how many times you would dial a telephone number? And the question asks you, how many hours? And the question asks you, how many different majors? Okay, so those variables go to different directions, You have to transform all 15 items into z-score in this situation, so that they all go into the same direction. Use standardized data. All right, so that are the examples of internal consistency. Now, the assumptions under internal consistency reliability. Just 3 assumptions. Assumption 1, the parts of the measure must be equivalent. Okay. If you use split half, both half must be measured the same underlying dimension to the same extent. And if you use the coefficient alpha, all items must measure the same dimension. So this assumption said all items must go to the same direction. That is assumption 1, must be equivalent. Assumption 2, errors in measurement between parts are unrelated. So if you have a split part, there are errors in the first part, and there are errors in the second part. The errors from first part is independent with the errors from the second part. And assumption 3, all item or half-test, an item, this is an, not all, sorry, an item or half-test score is a sum of its true and its error scores. Okay. To help you understand assumption 3, you can think about this. Okay, so the average of y, it is maybe not. So this means, this assumption means there are some errors and plus the true numbers that should be the test score. So test score is the true number plus or minus some error. So those are the assumptions about internal consistency. Now let's look at the data file for lesson 37. In this data file, we have 10 items. Okay, we have 10 items, item 1 to item 10. Item 1, I keep my emotions under control. Item 2, under stress, I remain calm. So I give you a few moments, you read over those items. So once you have this data, before you do any analysis, we want to ask question. How reliable is these 10 items? Measure of emotion control. How reliable are those 10 items? Okay. So the items share the same matrix because all items measured use the same scale, the Likert scale, 0 to 4. 0 represent completely disagree, 4 completely agree. Okay. Now let's examine items 3, 4, 6, 8, and 9. So if you look at those Let's look at item 3. I like to let people know how I am feeling. So this item is express your emotion openly. But our objective is emotion control. So this question is about express your emotion openly. So it is opposite of our direction. That's the reason item 3 need to be reversed. Item 3 need to be reversed. Let's take a look at item 1. Why item 1 do not need reverse? Item 1 said, I keep my emotions under control. This item is in the same direction with emotion control. So our objective to measure what? Measure emotional control. That is our objective. If our objective to measure openly express my emotion, in that case, you should reverse item 1, 2, 5, 7, 9. Is that clear? Depending on your objective. Our objective in this example to keep emotion under control. Any items related to openly express your emotion need to be reversed. So item 4 need to be reversed. Item 6 well adjusted who confident enough to express their emotions. 6 need to be reversed. Item 8, I let people see my emotions. 8 need to be reversed. You open up your emotion to other people. Item 10, I try to get along with people. And not create a big fuss. And this is also need to be reversed because you are not trying to control your emotion. Okay? So those items need to be reversed. And remember, our scale is 0 to 4. 0, 1, 2, 3, 4.
Professor,
Yes?
for the last item, it says item 9 in the PowerPoint, not item 10.
Oh, not item. Oh, thank you so much. Item 9. Item 9 need to be reversed. If I am angry with people, I will tell them. So you openly express your feelings. I will tell them. Thank you so much. Okay. So item 9 need to be reversed, not item 10. And when you reverse, item 0 becomes item 4, 1 becomes 3, 2 is 2, 3 becomes 1, 4 becomes 0. When you reverse item. Okay. Okay, now how do we reverse item in SPSS? We need to open data file lesson 37. Okay. So go SPSS. Oops, I have too many data files open. Maybe I need to close a lot of them. Okay. Maybe never mind. I will open data file, lesson 37. So I pause for a moment, give you some time to open. At the same time, I try to check the chat area. If somebody see the message, can you please, if you can answer the question? Okay, no questions. All right, so this is my another data. try to close some unnecessary data. No. Sleep. Okay, this is our data lesson 30. This is the one I actually know this. This is lesson 38. Okay, this is the original file. Okay, hope you also get this one. I will suggest you save this file in different location using different name. So I'll click save as. See, I will save in different location. The file name is lesson 37. In my case, it is demonstration. Maybe lesson 27. Demo. All right, so we need to reverse some item. So item 3, 4, 6, 8, and 9. Our textbook, after the reverse, they recorded into different variable. You could do that, no problem. But I just want to keep things simple. I want to record into the same variable. Record into the same variable. You could record it into different variable. Okay, so I'm going to do transform compute variable, not compute, transform, and then record into same variable. You could select the next one, record into different variables. That is our textbook example. Okay, but I choose this one in record into same variables. So which variable we need to inverse? We need item 3. So you click item 3, press and hold down Control, select item 4, item 6, item 8, item 9. Those are the items we need to reverse. And then press this arrow key. Okay, and after that, with all these items selected, you can just do reverse one time. It will apply all of these 5 items. Okay, how? You click Alt and new value. So Alt value is 0. The new value should be 1. Okay, Alt value is 0. New value is 1. Click Add. Okay, keep on going. Alt value is 1. New value is 3. Click Add. Okay. I pause for a moment to see if you have any questions.
The lecture slide, you had it 0 going to 4.
Sorry, oh, I haven't finished yet. So alt value is 2. new value is 2. And then old value is 3. New value is 1. Click add. Lastly, old value is 4. New value is 0. Because I selected all the 5 items together, I just need to do this one time. It will apply for all 5 items. You could repeat yourself for 5 items, do 5 times, no problem. Okay. So after that, you click continue, and then you click OK button.
Professor,
Yes.
I'm still confused about why the first one is 0 to 1 and not 0 to 4.
0 should be go to 4. Yes.
You did
Did-
0 to 1.
Oh, I maybe made it unintentionally. Thank you so much, Jackie. Then I messed up. See, I did 0 to 1. That's completely wrong. Thank you so much. That is an unintentional mistake. What do I do now? So I'm going to maybe don't save this data file. I need to open again. Do you want to save? No. So get a fresh data from the data. Do you want to know? So get lesson 37 again. Okay, then save as, file, save as. See, that's the reason why you want to save different location, different name. Something happened, you can go back to original data. Okay, I will just call L37, that's it. Yeah. Try to keep the chart window open. Okay, I'm going to redo it. Transform according to the same variable. So I need to select item 3, item 4, 6, 8, 9, okay. And then out a new row. If you add a 0, the new value should be 4. 1 goes to 3. 2 goes to 2. 3 goes to 1. 4 goes to 0. Okay, and then continue and click OK. All right, so you reversed those items. Okay. And next, you are going to conduct reliability analysis. Reliability analysis. You want to get coefficient alpha. Okay. To do that, you go to Analyze, Scale, Reliability Analysis. And after that, you select all items by click and press Shift. Select all items, move them into the item box. After that, click Statistics. Usually we need 3 check. Item, check item, check scale, check inter-item correlation. Click OK, but click Continue. When we use reliability analysis, now we are using alpha, model using alpha. Do we have other model? Yes. You need to know all of those, the name of the model. This might be a concept questions during final exam. So the question might be, beside alpha, what are other models beside alpha? The answer is omega, split half, Cartman, parallel, straight parallel. In this lesson, we are going to introduce two models. One is alpha, the other is split half. The other one, you just need to know at the concept level. So make sure alpha is selected, and then click OK button. And now this is your output. And how do you analyze this output? Okay, so this is your output over here. I'm going to maximum this screen. Okay. So our Cronbach alpha 0.872. Okay. Anything greater than 0.7 is good. Means the internal consistency is achieved. Okay, so as long as it is greater than 0.7, it is fine. And total, we have 10 items. And this one is a Cronbach alpha based on standardized items. Okay, standardized items means if translate original data all into their value. Okay. And this table is, maybe I want to make it bigger. Yes, I can make it bigger. The next one is item statistic. Remember, we have 10 items. This is the mean value for item 1, standard deviation for item 1, etc. Okay, those are just descriptive for each item. And here we have inter-item correlation matrix. In this table, you actually just need to read half of the table. You see the diagonal with 0 or not with 1. That means the correlation of item 1 with item 1 is 1. Correlation of item 2 with item 2 is 1, etc. Okay, so you need just to read half of the table, this part or the upper part. So let's explain this number. 0.463 means the correlation between item 2 and item 1 is 0.463. Okay, and in this table, you should see all positive. If you see a negative correlation, you need to reverse. Maybe some item need to reverse, but you didn't reverse. Okay, to make sure items are consistent, they must be all positive. If you got negative, you messed up. You need to go back to original data to reverse again. Okay. So this is a correlation matrix. And the next one is a scale statistic. A lot of textbooks, including online resources. If you Google what is a scale statistic, looks like nobody want to explain this. So this is I will fill in the gap. Okay. So what is this? This mean 21.33 mean. To answer this question, we are going to go to original data. So look how many respondents in our data, original data, how many people surveyed based on this data? How many? Yeah, 50. Thank you, Yoda. We have 50 people being surveyed. Okay. And for each people, how many items I asked them to fill out? How many items? 10, right? Each people will fill out 10 items. Total, we have 50 people. So how many total number here? You see where is my mouse? How many total number for all 50 people? Jackie, you have answer? How many total items here? Anyone know? Yes.
500.
Wow, you are brilliant. Correct. Total, we have 500 items here. Okay, here. And now, if you add all those 500 items, can you do addition? Of course, you can do it, okay? Add them all, divided by 500. And the result, you are going to get that 21.32. Okay? So that is a scale, mean 21.32. Where this number coming from? Okay. Similarly, what is the variance? Variance. Okay. All right. So from this procedure, we conclude our internal consistency is pretty good because the Cronbach alpha is 0.87. Okay. And this method is coefficient alpha method. Okay, alpha method. Next, we are going to use split half. So this is alpha method. Next, we are going to use split half. Computing split half coefficient. Remember when we divide original 10 items into half, each half must be equivalent. Okay. We choose the first half is item 1, 3, 5. We do not select 7, 9 here. We select 8, 9. The reason is we want to balance two halves. We want to make sure both halves have under control and expression items. Okay, and for second half, we choose 2, 4, 6, 7, 9. If you read each item original, this is the best split half. Okay, the purpose is to create equivalent parts. So once you have this, create two halves, let's do reliability analysis again. Okay, so this is the steps. Let's use SPSS, but before that, I want to check the message. Okay, there is a question here. Should 6 and 7 be different half then? Good question, Eric. 6 and 7. So let's look at it. Item 6. The question, we have a question. Okay, question is, should 6 and 7 be different item? So different half. 6 is well-adjusted individuals are ones who are confident. 7 emotions get into the way of clear thinking. Okay. You could have different method to create split half, Eric, but this is one way to do it. Just to make sure each half have balanced item for under control and expression items. Okay, and also make sure the ordering of the items on the manual. Okay, you could put 6 and 7 into different categories. It could be, but this is one way our textbook arranged. Okay, maybe misunderstood. Okay, so the objective divide 10 items into 2 groups. Each group have the balanced item between under control and expression. That is the objective. Okay. All right, so now let's do the SPSS. So now we are going to use split half. Split half. All right, so go analyze, scale, reliability analysis. Now quick reset. Okay. After you quick reset, we want to put item 1, 3, 5, 8, 10. Select 1, 3, oh no, using the control 1, control 3, press and hold down control. So 1, 3, 5, 8, 10. So move to the item. And next, select item 2. Press and hold down control. Item 2, 4, 6, 7, and 9. Using control to select non-adjacent. Okay, so move to next one. And then quick statistics. Under descriptive, check out item, scale. Under inter item, check correlation. Quick continue. And in the method, please select split half. Method or model split half. Okay, split half, then click OK button. And you get this result. Reliability statistic. So any questions? So this is the result. For part 1, our Cronbach alpha 0.786. For part 2, Cronbach alpha 0.757. Those two numbers are very close. That's good. That means they're pretty evenly distributed between those two parts. If you have those two numbers, there is a big difference. You need to regroup, you recreate the half. Okay. Remember, total we have 10 items, so each part has 5 items. How about if you have 11 items, when you split half, one part has 5 items, another part has 6 items. In that case, on equal lengths, you should report the Spearman-Brown coefficient under unequal lengths. Report that number. But in our example, we have equal lengths. Okay. All right. So that is, in summary, in lesson 37, we use 2 different methods. One method is coefficient alpha. The other method, split half. Both methods achieved satisfied result because we got Cronbach alpha greater than 0.7. That means internal consistency is not a problem for our data set. Okay. All right, any questions? Any questions? Okay, shall we take a break? After break, we'll do lesson 38. 38, we probably need at least 1 hour and a half. Okay, 38. So shall we come back at 5 after 2? Okay, so break. Back at 2:05. I'm going to stop recording. When we're back, I'm going to start recording again.